purpose of this video is to actually introduce you to these things over here. Alright, briefly go through with you what are these things going to talk about, because there is certain purpose that I want to convey over here. The first thing over here is the first understanding that I want to convey is the canonical form. Alright, this canonical form over here is in terms of A and B. Alright, but it is in terms of what? Alright, it is in terms of this thing, your transformation, your transfer function. Your transfer function can be in terms of this thing. Your B over here is somewhat your this thing over here. Alright, maybe I should zoom out a little. Alright, well, your A over here is somewhat this thing over here. Okay, so somewhat later on you will get to see something like this. Alright, your transfer function ys over u of s can be rewritten as y of s over z of s times z of s over u of s. Okay, so where your y of s over z of s is actually your top of it. Alright, okay, I don't know whether is it top or not, but at least you get to know that maybe I should be right. The transfer function y of s over u of s can be rewritten as y over z times z over u. It's a chain rule. If you cancel, you have y over u back. Alright, so this is something that you need to understand for this case, such that you can plot out all this canonical form. Alright, this whole thing over here is a canonical form, and using a canonical form later on you get to see that he actually plotted out somehow, I don't know whether is it in our course, but you're going to represent your system in terms of a signal flow graph. Alright, so in the later parts of this video, alright, if you were to click at the back over here, alright, you get to see all the signal flow graph. You get to see all these things. These are all your signal flow graph. Okay, and you explain. So I suggest that you watch with a speed of ×2. Alright, because all the stuff is just derivations, and I think that you already fully understand everything. Alright, there is something that I want to add on because this is not being discussed in the video, but if you remember, x dot t is equals to axt plus but, right, which is ax plus bu is equals to x dot. Alright, so therefore as you can see, your a over here is being plotted with your this thing over here, which is your poles. Alright, this thing over here are all your poles, and take note that your s over here, you can see there is no coefficient. This system over here is a monic, alright, because there is no coefficient at the front. Just take note of it. So your poles over here is simply your closed loop transfer function. Alright, so you're putting your closed loop transfer function over here. If you were to remember back your CP over 1 plus CP, for example, okay, if it's not exactly the case, but at least you get to see that the poles over here is something like this. Alright, so you're plotting your poles over as your A, or you're plotting your zeros, your numerator, as your C. Okay, over here. So that is something that you need to also understand about it. Alright, so these are the things that I just wanted to take note. Alright, there's some variations between converting your transfer function. Alright, for the canonical form or controllable form, you're gonna use somewhat your transfer function, this thing over here, the chain rule. Alright, for the observable form, alright, something is gonna be a little bit different, so you need to take note of that also. Alright, and then I'll just leave you with that, and you just watch all these videos, and therefore see you soon.